Okay, so now we're going to talk about the theory of plate tectonics, which is taking continental drift one step further. So the theory of plate tectonics looks at how the plates move. This theory was developed in the 1960s and looks at the Earth's crust that's broken up into segments. These plates move on the plastic layer of the mantle, which is known as the asthenosphere. Most references say that there are 15 segments or major plates on the Earth's surface. Within those 15 plates, there are many smaller, minor plates. So here we have a world map that shows all of the major plates of the Earth. Most of your plates are going to be labeled after either major ocean basins or continents. So for instance, here we have the Eurasian plate. The Eurasian plate encompasses all of Europe and most of Asia as a tectonic plate. We also have the North American plate, the South American plate, the African plate, the Pacific plate takes up the entire Pacific Ocean, the Antarctic plate, which is down here, and we also have the Australian plate. We also have a few that aren't associated with an ocean or a continent. Those ones you're just going to have to kind of remember. For instance, the Scotia plate is down the southern part of South America, the Nazca plate, west coast of America, Cocos plate, and then you have the Juan de Fuca plate, which is up on the west coast of the United States. So how does it all work? This is the material that Wegener and Hess weren't able to really figure out of how these plates were moving. So first, what are plates? Well, plates are pieces of lithosphere, typically made of granitic crust that is lighter and less dense than oceanic crust. These plates fit together along cracks called plate boundaries. Convection currents is movement within the asthenosphere. So density differences drive plate motion. Molten rock is less dense than solid rock, and then oceanic crust is more dense than continental crust. So just like when we talked about atmosphere, the less dense material rises to the surface, it cools. As it cools, it starts to travel downward, cools, and then sinks, warms back up, rises, cools. As it cools, it pulls that lithospheric plate with it, goes down, and warms up. That's called a convection current, and that should seem very familiar from when we talked about atmosphere and weather. Okay, so here's another map of the world plates, but also this one has kind of directions of motion and rates of motion. So one of the first questions that you have for Earth's puzzle is, what plate do we live on? Well, we live here, so we are on the North American plate. And you'll notice that there isn't any plate boundary really near us in New Hampshire, which is why we don't have any volcanoes and why we don't have any earthquakes really in this area. The next question is, well, what plates do we border? So here is the Eurasian plate, so we border the Eurasian plate, border the African plate on the east coast, and on the west coast we border the Pacific plate, the Cocos plate, and the Caribbean plate are all plates that we border. Now you'll notice that these plates don't all move in a uniform speed. So some of them are moving very quickly or spreading apart very quickly, or they're subducting very quickly, which means there's a lot of plate motion. So like here, the Nazca plate and the Pacific plate are moving apart. So that would be a divergent boundary, which we'll get into in a minute. They're moving apart at a rate of about 17 centimeters per year. And they're subducting, which means one plate is going underneath the next one, at a rate of about 7.9 centimeters per year. Because these rates are not all the same, there's a lot of shifting and movement within the plates themselves. So sometimes an earthquake up here could cause an earthquake down here because of the motion of the plates. So there are three types of plate boundaries that we're going to cover. The first one is divergent. So this is when two plates are pulling apart, when magma is rising up from the asthenosphere, creating new oceanic rock. Then you have convergent plate boundaries. This is where two plates are colliding together. We're going to subdivide this particular boundary type into two subtypes shortly, but it's when two plates are colliding together and something happens, whether one goes underneath the other or they collide at the same density and they create mountains. The third type is a transform boundary. This is where two plates slide past each other. So this slide goes into more detail about the different types of plate motion. So the first one we're going to talk about is divergent. This is where plates are moving apart. Here, new crust is created, magma is coming to the surface and forming into rock. This rock is typically extrusive and basaltic, or mafic, because it's coming from the asthenosphere, which has a lot of iron and magnesium in it, cooling very quickly. In the oceans, this is known as a ridge, so it's an underwater volcanic range. And on land, because there is already continental crust there, you end up having a rift form. We'll talk about that in the next slide. Convergent plate boundaries are where two plates are coming together. Remember, I just briefly talked about that there's two subtypes to convergent. There's convergent subducting and convergent collisional. So when you have continental subducting, it's when you either have two oceanic plates colliding or an oceanic and a continental plate colliding. This has to do with different densities. Here you have crust returning to the mantle, forming back into magma. Now you'll notice when I talk about two different densities, you might be noticing, well, oceanic plates should have the same density. If two oceanic plates are colliding, shouldn't they have the same density? No. The reason for that is typically when two oceanic plates collide, one of them is older, which makes it colder and more dense. So when two oceanic plates collide, the older, denser one subducts underneath the younger, less dense plate. When you have oceanic and continental plates colliding, the oceanic plate has more iron and magnesium. The continental plate has more silica and oxygen, making it less dense. So when those two plates collide, the oceanic plate subducts back into the mantle, forming back into magma. The other type of convergent plate you can have is a convergent collisional. This is when two continental plates come together. And in this case, they do have the same densities because they're relatively the same age. So when two continental plates come together, they crash together and form mountain ranges. The third type of plate motion is transform. This is where plates are slipping past one another. They're either going in the same direction at different rates or they're going in different directions. Similar to how you feel when a 18-wheeler passes you on the highway. They're going in the same direction, but it feels like you're moving backwards. So that motion is the same. So transform boundaries are when they're slipping past one another. In this instance, the crust is neither created or destroyed, but you do have offsetting. And offsetting is caused by a wide variety of earthquakes, both small and large. So this slide tells you what kind of features you see on Earth. So if you were to look at a bathymetry map, which is a map of the ocean floor and all of the features on the Earth's surface, these are the things you would be looking for. So with a divergent plate boundary, you'd be looking for rift valleys or ridges. So if you have rift valleys, it's continental crust that's pulling apart, creating a separation of the plates and a new ocean. So the reason for that is the plates are pulling apart, but the continental crust is so thick that it takes a long time for them to pull apart and separate. So you end up with these rift valleys. So it ends up being like this blockade of faults. And over time, those will actually separate. Water will flow in here, creating a new ocean. Oceanic crust, you have mid-ocean ridges and volcanoes forming. This typically happens underwater, and you end up with underwater volcanic ranges. When you have convergent plate boundaries and they're two continental plates, you get mountain ranges, similar to the Himalayas or the Andes. Then you can also have two oceanic plates or an oceanic and a continental plate. One is more dense than the other, so you have subduction happening and volcanoes forming. With a transform boundary, there isn't any real feature that you can see on the Earth, but it's an area that's highly susceptible to earthquakes. So the plates move against each other, stress builds up, it's released by an earthquake. So often when earthquakes occur, we talk about an earthquake happening on a fault type or a fault line. So what does that mean? Well, fault types are caused by plate motion. A normal fault is created at a divergent boundary. So as plates pull apart, this causes blocks of crust to pull apart. Makes sense, as they're pulling apart, things have to kind of stretch as well. So rock layers above the fault move down compared to rock layers below the fault. The second type of fault is a reverse fault. This occurs when two plates collide, and it's pretty much just backwards to the one we just talked about. The rock layers above the fault surface move up relative to the layers below the rock surface. This type of fault is a strike-slip fault. This occurs at transform boundaries. So as plates move, they stick together and then slide. These plates can be moving in opposite directions or the same direction at different rates. At this fault type, you end up having a lot of earthquakes that are formed here. So now let's look at everything as kind of a big picture. We're going to start over here with rising magma in the asthenosphere. So rising magma comes up through the rift zone, pushes out older rock, creating new rock. As it pushes out, this is known as seafloor spreading, which we talked about last class. And as it gets pushed out, it gets increasingly older. As it gets pushed outward, it gets closer and closer to a continental plate. With a continental plate, it's going to come towards the continental plate and subduct underneath the continental plate. From here, that's known as a subduction zone. When the subduction zone melts that rock back down, creating magma. The magma then rises to the surface and you get volcanic mountain ranges. You can also have a collisional zone, so two continental plates colliding together. They have the same density, so you end up with a folded or faulted mountain range. So now that you guys are done the video, I want you to make sure your notes are complete and answer the questions at the bottom of the Google form. Well, I'll see you tomorrow.